I would like to show you an example for this homework, the number 7, part B. In this part B, we are trying to figure out the rate of convergence of this function when h is approaching 0. The limit is fairly easy to check. You just plug in, use L'Hopital's rule. The limit is 0. Now we are going to follow the definition. So this is what we are trying to do, right? So this is what we are trying to do. Subtract its limits. We want to do some algebra here so that we can bound the result by a constant times of a well-known function. Usually it's h to some power, some power. So this is the goal. Like I said, the hint is use Taylor theorem. You try to expand cosine. Try to expand cosine using Taylor theorem. In order for us to find the Taylor theorem, just for convenience purpose, I already found the derivatives of cosine. So first derivative, second derivative, up to third derivative. I know I don't need the fourth derivative. Now, also I kind of lay out the work already. So if I want to find the first order Taylor polynomial, so this is my actually P1, right? Because this power of x is just 1. And here this is my remainder term. This is my R1. So this is the first order polynomial. And then I should have that. Now, in terms of cosine, that's what I have. So cosine h is f of 0, which means cosine of 0. So cosine of 0 is 1. That's why we get the 1 right here. And f prime of 0 is f prime is sine, negative sine. So f prime of 0, sine 0 is 0. So the next term will be 0. And now let's look at the remainder term. Here, the remainder term, this guy is xi. So f double prime is negative cosine, and therefore I have negative cosine xi divided by 2. And this is because we are talking about h here, so I just plug in h squared. That's how we get to the this expression, this result. Okay, so again, this is my first order Taylor polynomial, and this is the remainder term. Another way to write this f of x is you can, there are many ways depending on what's the order of Taylor polynomial you want to use. So this time I'm going to also write the second order polynomial. And now I just apply that. So cosine h is, again, these two terms, we just talked about those. Now let's look at the next term right here. So f second derivative is negative cosine. So when I plug in 0, it's going to be negative 1. So negative 1 over 2 factorial, which is 2, and then h squared. And this is my remainder term. So this is my remainder term. Now this is supposed to be xi, so I plug in the xi into the third derivative, which is sine. So sine of xi over 3 factorial, which is 6, h cubed. The reason I provide you both is to hopefully when we do this problem, you can try both. You can either try this one or try this one, and soon from this experience you know which one to use. One works, the other one doesn't. That's the reason I provide you two solutions. So let's first try the using this guy, okay? The first order result. So from here we have 1 minus, what is my cosine h? So I should plug in this guy in here, right? So I'm gonna do that. Let me do that. So it will be 1 minus cosine xi over 2 h squared, right? And then divided by h. Okay, so I'm gonna simplify this guy, and you can see that 1 and 1, these two 1 will cancel out with each other, and this minus sign, there's a minus sign, so it becomes plus sign after the simplification. So after that, we will have cosine xi over 2. Here I have h squared, and still I have the bottom one, which is divided by h. Don't forget the absolute value. And now h can be cancelled. So in this case, I'm left with cosine xi over 2. And again, h cancel out with 1h, just h. And you can now bound this cosine is less than or equal to 1. So we know it's gonna be less than or equal to 1 over 2 h. And you can now see this is actually bigger of h, right? So it works out nice. Let's try to see the second one. I'm gonna use a different color. So this time we are gonna use this one and to plug in here, okay? So I'll do that here. So this is equal to 1 minus. So what is cosine h? I'm gonna use the whole expression. So 1 minus 1/2 of h squared plus sine xi over 6 and h cubed, and divided by h. Okay, so after that, you drop the parentheses, and 1 will cancel, right? 1 and 1 will cancel. And then all the other terms change sign. So I'm left with 1/2 of h squared minus sine xi over 6 and h cubed divided by h and absolute value. And cancel 1h. You are left with 1/2 of h minus sine xi over 6 h squared. Now you have trouble to bound in this time because you have two terms here, and it is, well, how do you bound? It's tough, right? So therefore this is not a good way to do. This is the correct way to do. Now as a final note, what's the order that you're going to use? The correct number of orders to use will give you a result like a single term at the end. When you have, there's got to be some xi somewhere. And if you have choose too many terms, you end up with this one. And if you choose too less terms, you don't have enough terms to cancel the numbers. So this is one example to help you with the problem number 7. So I did this one. For the other ones, you have the opportunity to accumulate the experience, and so that you know how many terms to use.